Good morning, students. Today, the topic is equilibrium of fluid in given field of force. Today, we derive the formula dP equal to rho x dx plus y dy plus z dz, where P, rho denotes the pressure and density and x, y, z denote the resolved paths parallel to the axis of the external forces per unit mass at any point x, y, z. For this, we have a point P and the coordinate of P is xyz. We draw a parallelepiped that is PQRS, P dash Q dash R dash H dash, where the sides are PQ equal to delta Y, PS equal to delta Z, PP dash equal to delta X. Similarly, PQ equal to delta Y, PS equal to delta Z, and P dash equal to delta X. Volume of the fluid in the parallelepiped is equal to del X, del Y, del Z. And we consider the mean density of the fluid is equal to rho. Now we consider equilibrium along x-axis. In x-axis we have this face, that is PQRS, and we have P dash Q dash R dash S dash. The first force or thrust is P delta Y del Z. That means in the face PQRS there is a pressure small p, and in the face P dash Q dash R dash S dash there is a pressure P plus delta P. The area of the plane PQRS is del y del z. So the thrust is P delta y delta z. Similarly, the thrust on the plane P dash Q dash R dash S dash is P plus delta P del y del z. Now, the volume of the fluid in the parallelepiped is del x del y del z. Rho is the mean density of the fluid. Capital X, Y, Z are component of external force along X, Y and Z axis. So, the total forces acting along X axis are P del y del z, P plus delta P del y del z, and we have capital X as a component of external force per unit mass along X axis. So, the total external force along X axis is equal to X, and the total mass within the parallelepiped, this is equal to del X, del Y, del Z and multiplied by rho. So, at equilibrium, forces along x-axis is given by P del Y del Z, rho x del y del Z equal to P plus del P del Y del Z. That means the pressure difference this and this balances this force. So, after calculation, we have del P upon del X equal to rho x. This is along x-axis. Now, similarly, at equilibrium, forces along y and z axis. We have del P by del Y equal to rho y, del P by del Z equal to rho z. Now, consider del X tends to 0, del Y tends to 0 and del Z tends to 0. Then the mean density will become the density at P, X, Y, Z. So, taking the limit, we have del P upon del X equal to rho X, del P upon del Y equal to rho Y, and del P upon del Z equal to rho Z. Since the pressure is equal to function of X, Y, and Z, now we assume that pressure is function of X, Y, Z, and this is equal to F. So, dP can be written as del F upon del X dx, del F upon del Y dy plus del F upon del Z dz. So, dP is equal to del P by del X. Why? Because F is equal to P plus del P by del Y dy and del P by del Z dz. So, dP equal to rho x dx plus rho y dy plus rho z dz. So, dP equal to rho x dx plus y dy plus z dz. Thank you.